Good morning.
Good morning, sir.
Good morning, sir. What was the discussion in last class? What we have discussed in our last class?
Sir, if the position of coupler is given, then we have to find the fixed points.
Yes, we were discussing motion generation problem. In motion generation problem, the position of the coupler is given, and from that position of the coupler, we have to find out what is the what are the other dimensions of the coupler. Okay, so let me share with you this. Sharing entire screen. Is it now visible, this?
Yes, sir.
Okay, so what we will do, we will first in your problem it will be given where the position of two hinge points O2, O4 and three positions of the coupler that will be given, and what we need to find out is the other hinge points like A and B, which are on the coupler. So when you find out those hinge points A and B on the coupler, then you will get the actual uh, dimensions of all other things. Okay. So today's problem we are discussing here, I think it's a motion generation problem. And what is the lecture number today? Do you remember?
8.
This is yeah, today is our lecture number 8. 8, when we are discussing motion generation. And in this motion generation, the specific problem we are solving today is this. There is so the three position of a coupler is given. Three position of a coupler is given, and three position of a coupler is given. One thing, and another thing which is given is two fixed points uh, which are O2 and O4 are given. Okay, we have to determine hinge points on the coupler. These points are A and B. So if we draw a four-bar mechanism like this, to understand this, what are these points? I am just this A and B. So let me save it, otherwise some issue may appear. This is motion generation. Okay, now let us take some arbitrary position. We don't know whether a solution is possible for that or not, but let us take three arbitrary position of a coupler. So I am drawing a coupler here. I'm drawing a coupler here. Suppose we have, I'm sorry, we have a coupler which looks like this, and this coupler, let's say at the this is the middle position. Let's say this is the middle position of the coupler, uh, and we have to, actually in the problem it will be given the other two positions. So suppose the other positions of the couplers are um, like this is one of the position, and we have the other position is okay, this three position. Let me place it somewhere here. Okay, so I will give some different colors to it so that we can differentiate between three different positions. Suppose this is a color like this. Okay, okay. And let me do one thing. Okay, so these three positions are there for a coupler, and let's say this is the position one of the coupler, and this is position two, and this is position three. This is given. This is a requirement for some application. Suppose you have given this requirement, and always there be some kind of constant of space. So from those constants, one can uh, specify the position of the two links, specify the two hinge points. Suppose those two hinge points are, this is one hinge point. Okay, I am drawing a bigger circle just to just to just to say that, then that is a point, right? That is a point. Just to exaggerate it, I have drawn like this. And suppose the other point, hinge point, is here. Okay, this is the other point. These are the two hinge points. And according to our notation, what we do, we use this symbol O2 here. We use this symbol O2 here, and obviously we have to do something. This point is O2 and this point is O4. Okay, our task is to find out this O2 and O4 is given, and these three positions of the coupler is given. Our task is to find out where are the hinge points A and B, so that this motion we will get this motion. Let us try this uh, to solve this problem. It is not always true that any configuration given and you will find out a solution, because it has to satisfy the all the criterias. Okay, so we start from what we will do now. We will do the inverted position of O2 and O4 with respect to position 1. We will keep this position 1 fixed, and then for position 2 and position 3, we will find out what are the inverted position of O2 and O4. Okay, to do that, first thing what we will do, we will first copy the same image here in the another another place. We will copy the same thing. So this copying you can do using your trace paper. Okay, you will use trace paper and copy it, and then you will move it to some other place. Okay, suppose this way I move the, here I have drawn it again. Okay, all right. So now let me come back to our discussion. This is the mechanism we have. Now we will do the inverted position. So inverted with respect to position 1. First thing what we will do, we will now copy this position 2 coupler and these 2 points O2, O4. Okay, coupler O2, O4. Before we do that, let me make this change color change, and to just see that this is position 1. For position 1 we have this O2 O4, but let us now copy this position 2 O2 O4 for position 2. Okay, so uh, let us copy this also, so that now we will shift this to the first position where we need to go. This is the first position, and in this first position we will just uh, paste it. We have to merge these two things. So you need to rotate. How much you have to rotate? It is easy for you, uh, because you will have the trace paper. You'll just keep the trace paper and find out where it is exactly matching. So for our case, what we will do, we have this option. So I just shifting it and placing it here. So now this position 2, I have merged it with position 1 here, and for that we have a new position for O2 and O4. Okay, so where is O2 and O4 for this new position? You can see it here. Okay, you can see it here that this new positions O2 and O4 are here. They are overlapping somewhere here, so I want to remove some of this writings. This is new O2. Okay, so I'll write it once again, because these are old O2 O4, but this is new O2, and let us call this new O2 as, this is O2 inverted with respect to position 1, O2 2. This point is O2 2. This point is O4 2. Second step we have done. In the third step, again, we'll go back to the original figure. There, we'll select this third position of the coupler. And for the third position, obviously, the O2 and O4, these 2 points will not change, right? I'm just copying O2 just to see. So actually you have to copy this coupler and this point and this point. To just see which one is O2, I have copied uh, this marking. Okay. So on your this by this option, what you are doing on your trace paper, you have marked. Okay. Now you move your trace paper to this position 1 here. Okay. So before I do that, let me rotate. Do you remember how much rotation I have given to it?
45 degree.
Okay, so that means if I want to match with it, how much rotation I need to give? 45 plus 30 degree, right? So that you will do using your trace paper. It is easier for you, but just I am using this software, so we have to do a rotation of I think 75 degree. Okay, and now what I will do, now I will shift this point, all these points to here. They are now exactly matching. Okay. See, I have copied this position 3 with respect to position 3, position of O2 and O4 that I have copied, and now I have pasted here. Let me change the color so that this is position 3 we can understand. So now we have a new point. O2 is here and O4 is here. Okay. So let us write that point somewhere here. I'm removing it, and now we know that this is O2. So let us write it. This is this is O2 with respect to 1 we have inverted. This is our third step, and this is O4 with respect to 1 we have inverted. Third position. Okay. What next? What next? What we will do now
Sir,
after
O2
getting
must
this?
be the
Follow.
sir, O2 must be the point near to coupler 3, na sir.
Yes. No, no, no. What are you saying? O2 must be the point near to coupler 3.
Yes, sir. In third case.
No,
Because we are
actually,
copying.
no, no. See, in this third case, O4 is nearer to 3. Okay. Can you see here?
Okay.
From here, you see O4 is nearer to. Now, I have done nothing. I have just copied. Okay. I have copied this position to this position. So we got the inverted position of O2, O3, sorry, O2 and O4. Three positions for O2 and O3, O4. Now what is the next step? If you remember, to find out A and B, to find out position of A and B, what we can do?
Perpendicular bisector intersection.
Perpendicular bisector of this O2. Let me draw that perpendicular bisector. Okay, so in this case, take this. That gives us the center of O2, and then this O22, then O23. So now we have to draw perpendicular bisector of these two lines, and they will intersect somewhere. That point would be point A. Okay, let me do that. So to do that, we will draw circles. Okay, and draw this joining line. This is one of the perpendicular bisector. Okay, now we will draw another perpendicular bisector. This is the center point. I draw this circle, and okay, now I have to draw the another perpendicular bisector. Starts from here. Let me, okay, so it's difficult. This is the perpendicular bisector, but I have to extend this line. Okay, so they are intersecting at this point. So that means this is the point. This is the point where, what is this point?
A.
E.
A point. This is point A. Okay. So to remove much ambiguity, let me remove these circles. You will just understand these are the perpendicular bisectors. Okay, this one and this one perpendicular bisector, and this is the point which is the I mean the this is the point which is actually A. Okay, so let me make it a solid. Okay, this point now we got is A, and where is point B? So to get point B, again what we will do, we will now join these points. Sorry, we will now join this point O4, O4, O42, O43, and from all this, for all these three, we will, sorry, these two lines we have, and we have to draw perpendicular bisector of these two lines. Now we draw the perpendicular bisectors. Okay, so let us use some other color. Now this, sorry, you have to choose a line that gives you one perpendicular bisector, and for the other perpendicular bisector we have this line. Let me remove all other circles. Okay, and we have to extend this perpendicular bisector so that it intersects somewhere here, and you have, this is the point, this is the point which is actually B, point B. Okay, now coming back to our problem, we have started with this, and then for the inverted motion of O2 and O4 with respect to position 1 for position 2 and 3, we have obtained here, and then we have drawn the perpendicular bisectors which gives us the points A and B, point A and B. So this point, this is the point which is A, and this is the point which is B. Okay, and this is point B. This point is B, and this point is A. Now you can ask a question, sir, the coupler is here, okay, and A and B point which must lie on the coupler. They must not lie outside, right? They must lie on the coupler, and they, how is the solution here? Okay, so what you can do, you can think about, like, this is your coupler. You can extend the coupler anyway, like this. you can say that, well, this is the coupler I have, and although this is not a very good solution, but this is a solution for this particular problem. Okay, now you can change the problem. Actual problem will be something else, and you will follow the same method to get these points A and B. Okay, one can also have, suppose I can design it like this. I can have a shape like this, where I made this portion of this portion is there is no material, but this whole thing is a rigid body, and on that rigid body you have two hinges A and B. Okay, so these two hinges A and B, and the original points O2 and O4. So now if you just draw the what is the 4-bar mechanism we get from here, which ensures this position of 1, 2, 3 when it is rotating, so then you will find out the mechanism. Let me copy that from here and we'll draw somewhere else. So this is position O, sorry, this is position O2, and this point is A to A, this is B, and this is, where was O4? This was O4. So can we copy it and draw it somewhere? Okay, I'm drawing it separately here. Okay, now you can see that we have this is the position, this is the point for O2, this is, sorry, this is A, B, and O4. So finally I can draw it like this. This is O4. You can draw it like this. This is O2, and we have, but it is something completing the mechanism. Um, Sorry. Okay, so this is the mechanism we have. O2, AB, O4. The solution we got for this problem, we got the solution like this. Okay, you can change the positions of this O2 and O4. Suppose I have given these two positions. You can change them. Suppose I in some other problem can be given O2 is here, O4 is here. So you'll have some other solution. Okay. Do you understand this process of getting this A and B on the coupler?
Yes, sir.
Yes, sir.
Is it fine? Or you want me to repeat this?
Sir, please repeat the last one, sir.
Last?
Yes, yes.
मतलब कहाँ
जी
तक
सर,
तुम समझे
आप
हो बताओ, कौन सा चीज रिपीट कराना बोल रहे हो, रिपीट
सर
करना?
आपने एक्सटेंड किया वो समझ में आया, लेकिन उसकी सर बहुत सारी पॉसिबिलिटी हो सकती है सर, वो भी समझ में आया, लेकिन सर ये वाला फिगर समझ में नहीं आया जो उसके जस्ट नीचे बना है, राइट इन द मिडिल ऑफ.
ये वाला?
यस.
I have no, means I have just drawn the simple 4 bar mechanism, O2, A, B, and O4. O2, A, B and O4. उसको मैं separately just draw किया, and here also you can draw the actual coupler is this one. So you have
Okay, sir.
to
Okay,
uh,
sir.
no, actual coupler is this one. This is not the, this is a part of the coupler.
Okay, sir. Got it.
है ना? It is for you, just for your understanding. To solve a problem, you have to draw this. Have you understood the process?
Yes, sir. I got it, sir.
Okay, or I hope all of you have understood the process, and this kind of problem I'll ask you in the exam. Okay, I'll give you the three positions. From these three positions, you have to get where is point A and point B. When you will do graphically, you will use a trace paper. Trace paper is nothing but just use a transparent sheet. You can use a marker to mark these positions. Suppose this from position 2 you want to this position, this figure and this figure parallelly you have to draw. Then you just copy this coupler position 2 and these points O2 and O4. So with respect to 2, you have O2, O4 here. Then just copy it to and merge it with here the position 1 and see where is O2 and O4. Same process you repeat for the third case. When you do that, you will get this O2 3, O4 3. Once you have these 3 points, then join them, get the perpendicular bisectors. They will intersect somewhere. So you will get A and B. Okay, fine. I am not writing the steps, so I hope you can write it on your own, the steps. Oh, so what you can do, you can go and mm, write down those steps for your own workout. The next problem which we are going to solve.
Sir, hello, sir.
हाँ बोलो.
Sir, is the steps important in exam?
Yes,
Okay, sir.
I'll ask you in the exam this kind of problem. Alright, also the recording of this class will be available to you, and you can see that recording also if you do not understand some step. Okay, the next type of problem we are going to solve is a path generation problem. Path generation problem. So what is a path generation problem? As I many time I told you that this is our lecture number 8, part 2. So in a path generation problem, you have, suppose there is the path of a point will be given. Okay, suppose I want 3 position of a point, like the first position is, let's say it is here. The first position of the point is here. This is the first position of a point. Just to show it properly, I have drawn not drawn a point, but this is a circle I have drawn. Okay, and suppose the second position of the point is, let's say it is here, and the third position of the point is let's say it is here. Okay, so these are the 3 points which is asked, your client asking you to give him these 3 points. Suppose this is sorry, Let me first save it. I'll send you these figures also. This point is, let's say, C1. For position 1, this is C1, and this is C2, and this is C3. These three position given that during the rotation mechanism is running, you have to ensure a particular point on the coupler must follow this path. Okay, and what else is given here? So this is a requirement. They must follow the path. And another thing which is given is the position of the O2 point. Suppose the position of O2 point is given and that point is here. This is O2 point. Okay. Suppose this point is O2 and it is given. Okay. Also, the point O4 is given, and that O4 point is, let's say, somewhere here. This is O4. So in the question, it is given this O2, O4, and you have to ensure these points. This is O2. This point O2 and this is O4. This is given. I have to ensure this. So for this problem, suppose we also take a point on the follower. On the follower, I take another point. Suppose this point also given on the follower. Here is a point B. This point is also given. This is point B1 is given. Now, given means what? I have to ensure this. In the process of design, I have to ensure this, and from the constants of space constant, you have these positions O2 and O4 are given. Now you can also assume another point on the coupler, or this is O4B is the follower. Now if we can find out position A on the coupler, so that can ensure these three positions C1, C2 and C3. Okay, so what is left? Let me first uh, write here the problem statement. The problem statement is this O2, O4 and B is given. So there is something, this C1, C2, C3 are also given. What we need to determine that position of A. We need to determine position of A because the last point is A, which is connecting the whole mechanism, okay, which is completing the mechanism. So if we can find out A properly, and then the on the coupler the C point is there. So when you move this O to a link, it will give you this C1 to C2 and C2 to C3 points. Okay. So in this process, what we can do, we have to find out A, right? So in this process also we find out the inverted positions of O2. Okay. First, we will now find out what are the means positions of B2 and B3 from this geometry, because you see this O2 O4 is a fixed distance, and since point B is, let me write it here, O4 B1 or O4 B link is a, this distance is constant. This distance is constant. Also, B1 C1, actually BC is constant. Why? Because B point and C point both are on the coupler. We don't know what is the shape of the coupler, but both of them are on the coupler. That means that is a rigid body and their distance, थोड़ी देर बाद है, their distance is always constant. Okay. So using these two information, we can find out B2 and B3. How to find out this? Can you tell me, somebody? B2 and B3?
We will cut two arcs, like the length of BC from C and O4B length from O.
Anyone else? Hello? So what I am now doing is I'm drawing a circle. I'm drawing a circle on which the B point would be there. Okay. I'm drawing a circle. Obviously, the point B would lie on this circle because O4B1 is a constant. Right. Now, next thing is this distance, the distance between B and C1, that is also constant because these 2 points are on the same coupler. Okay. So what we can do to find out C2, we can have a circle, we can draw an arc with respect to this C2, and that arc, the radius would be this radius, and that will intersect this green circle somewhere. That will give us B2 point. Is it not? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Anna? So let me draw that circle. So to do that, I just have shifted this. You will have your compass to do this measurement, but I have this is the way to measure it. So I measure and then I'm drawing this circle. Okay. It is now intersecting at this point. So this point is B point. Let us complete the figure and then we will write them. Now to find out point C, I now have to, I now have to draw another circle making this C3 point center. To do that, I am drawing now another circle. Okay. So now we have drawn the circle. Okay. It is time to now place P points on this intersection points. So here I draw circle. Here I draw a circle. This is B2 and we'll have the B3 point. Here we'll have B3. Have I done it correctly? Hello? ठीक है?
Yes, sir.
Yes, sir.
So let me write it here. This is B. This is B2 and this is B3. Okay, we have now B1, B2, B3, C1, C2, C3, O2, O4 done. What is left now? We have to now find out position. What is where is A? To find out A, the step is we will find out the inverted position of O2, right? I'm writing it here. Obtain inverted positions of O2 and get A, right? Because for these three positions, we will have three position of O2, right? So from these three inverted position of O2, again we will draw perpendicular bisector and get the intersection points. So that point would be A, right? Because A point has to means O2 is the center with respect to which A point is rotating, right? Then for the inverted position, O point is rotating, O2 point is rotating with respect to point A. Is it fine?
Yes, sir.
Yes, sir.
So, okay. So now the next thing is we have to draw inverted positions of O2. Can somebody tell me how to do that? Inverted positions of O2.
Sir, we'll copy the position of O2 with respect to C1, B1, and we'll copy it to C2, B2.
Yeah, right. So to complete this drawing, what I am now doing is I hope this is visible to you. बहुत छोटा तो नहीं हो गया. So first thing what we are doing, we will now copy all these points O2, O4, B1, B2, B3, C1, C2, C3. As we did earlier also, we have to copy all the things and at some new figure, then there we will do all the steps. Okay, so I am copying it and then we will move them to a new place. Let's say here. Okay, now we will find out the inverted positions of O2 for position 2 and position 3. So maybe we can for this position, this thing we can maybe let us not copy this C3 position because we want to find out the inverted positions. So let us not This is not required actually here. I have just kept the first position. Now we will copy one by one the second and third position from here, and then we will place it there. Okay. So the first step is, as you said, that we will now copy the position of B B B2. This is B2, and then C2 and O2. These three things we have to copy. We have copied now, and now we need to shift it to B and C. So just from here, let's go to that position. Okay. Although at this position you see this C, they are not matching. We need to rotate it little bit. So we will do it using trial and error method. You will have your trace paper, and it is easier for you to do that. Let us change the color so that we can understand them, that this is the position 2 properly. And first let us rotate it. I am rotating it by 10 degree. We'll use trial and error method, as I said. Not done. Let's rotate it another 5 degree. So almost they are this B and C we can match. Let's do that. So not exactly matching, you can see here some problem is there. So let me try little bit more. It is almost matching, so I have to now place it this way. Okay, they are matching now. So for this position now, if I change the color to blue, so this is now we have the new O2 point. Let's write it, this new O2 point. Uh, this is our new O2 point. O2, O2 to inverted with respect to position 1. The last step is now we have to copy the B3 position, the B3 position, C3 position, and O2. Let us copy it, and these three positions we will now match with exactly with this. This is the B point, right? We have to rotate it, and for this case, how much? Let's rotate it by, let's say, 40 degree. I don't know, but I am rotating it 40 degree. Not good. I have to rotate it back by, let's say 4 degree. Still not good. Rotate it back by another 2 degree. So let us rotate another by 1 degree. Okay, so now if you keep it on point C, B is still not matching with this. We will rotate another 1 degree. Another 1 degree. Now it is almost exactly matching. The C and B are almost exactly matching. Okay. So it's easier for you to do it in your using your trace paper. Now, see, let me change the color so that we can understand this is the point we have copied. Let me make it green. Okay, so now I will write this point. This point is, we have, this is our O2 point. From position 3 we have done it. So this is the point which is B1. Okay, with this now we have all the inverted position of O2. That means this is O2 for position 1, O2 for position 2, O2 for position 3. Now what we will do, now we'll draw the perpendicular bisector of O2, O2 2, O2 3. Okay, so to draw the perpendicular bisectors, simply we'll draw the circles. Okay, I have drawn several lines, but you need to be careful. Okay. So first, let us draw this perpendicular bisector. This is one of the perpendicular bisector, and this is another perpendicular bisector. Okay, let me remove all other circles uh, to avoid ambiguity. We have perpendicular bisectors, but uh, they must be extended such that they must intersect. Okay, to do that, what I can do, we can start from this position, and there's some limitation with this software, but it's good enough to serve our purpose. Okay, so this is a point which is the, what is this point?
A.
This point is A. Okay, so this point is point A. Okay, so with this we have now solved this kind of problem where I have removed this C2, C3 points, but you can see now actual mechanism. Let us now draw the actual mechanism. Let us now draw the actual mechanism. The actual mechanism will be passing through. This is point. This is point O2. We start from O2, A, B, O4. Okay, so the mechanism is finally, the mechanism is O2, A, B, O4 is the mechanism. And then if one can ask that C must lie on the coupler. So you can always design a coupler like है ना? Now you see that this is, if I can make a coupler like this, where this A point and B point are on the coupler, and we have this is O2 and O4 point. Now when you rotate this mechanism in this direction, what you will have, you will have C this C2 and C3 points. You will obviously achieve the position of C2 and C3 points when you will rotate this. Okay, at some point of time, the C2 and C3 positions, you will get it. So for completeness, let us copy this 3 points and place it there. Okay. So this is our C1, C2, and C3 point. With this, we complete the discussion on path generation problem. If you have any question, you can ask me. I can repeat it for you. Hello, have you
So
understood
can we,
this?
so
हाँ
one doubt.
हाँ बोलो बोलो, थोड़ा
So can we
लाउडली
get,
बोलोगे, मुझे सुनाई कम दे रहा है यहाँ पे.
ठीक है सर.
हम्म.
सर ऐसे नॉन लीनियर कपलर्स एग्जाम में आ सकते हैं क्या?
Why are you calling it non-linear coupler?
सर बिकॉज ए बी और सी सेम लाइन पे लाई नहीं करते, मतलब
It may
रेक्टेंगुलर.
happen in actual situation. In actual situation, you may be you always, there will be some cases, some robotic arm will be there which has to perform some kind of work, and then it is like this only coupler. वो तो तुम means in your book it is given that the coupler has to be just a line and connecting to. In actual case, when there is a mechanism, the coupler is not like that. Some operation it has to do, right? So that is why one of the way I have given, you can give another shape depending. We will come to this that when we will discuss the dynamic analysis, then you will see that depending this shape, you cannot make this arbitrary shape. Okay, because the dynamics is also important. When it is rotating, the inertia forces are there, they will be interacting. So the amount of torque required to rotate it, uh, you have to give that amount of torque to rotate it properly. So that means it is not that it is always arbitrary. Okay. Also, you can make arbitrary, then you have to find out, quantify what is the torque required. Right. So your question that yes, obviously. So what is nonlinear here? There is nothing nonlinear here. You have got this A B point, and we have to make a coupler so that the A, B, and C, all the points should be on the coupler. Okay. ठीक है. Any other
सर नॉन
doubt?
लीनियर रेक्टेंगल इन द सेंस दैट ए बी एंड सी आर नॉट इन द सेम लाइन.
I understand.
ओके, यस
Nonlinear
सर.
is a big word in our mechanics. Okay, there is a whole lot of huge subject, so it's fine.
ओके सर.
But means I try to convince you that there is no issue. What is the issue? You have to find out A and B. Okay, the problem is given. The positions of C are given. The length of this O4 B1, O4, O2 will give is given. From that, we have to find out what is the configuration of the mechanism. I hope this is all of you have understood the process, and I have not written uh, the steps. So what you can do, you can write it for your own. That will help you in the exam. Also in future, when you require this method, At that time, I am sorry, I have not drawn it correctly. And you guys have not pointed out. This is not O4, right? We need to go from this position to this position to this position to this position. This is O4. गलत था, ठीक है, उसको करेक्ट कर लेना. This is O4 point. Okay, if you have any question, ask me. The class is over. I have taken 5 minutes ज़्यादा नहीं है, ठीक है. Somebody asked me in between the class that sir, you are muted. कितना टाइम के लिए म्यूट था?
नहीं थे सर.
नहीं सर.
सुनाई दे रहा था ना?
हाँ सर.
Yes.
Okay, let me tell you, this Wednesday I am on leave, so tomorrow's class will be there, but Wednesday class again. And the next week I will take 2 extra classes. So last week we have 1 class and this week 1 class. Wednesday class will not be there, but lab will be there. Okay.
Okay, sir.
ठीक है. Let's meet tomorrow. Thank you for your attention.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.